Hey guys, this is Mr. Sakita. I hope you guys are staying happy and healthy at home. And hope you enjoy this section of the review. I'll be working through Unit 3. So let's jump right in. We've got number 30, write an explicit rule or formula for each arithmetic sequence below. First thing we want to do is figure out our first term and our common difference. See, I've got the formula over here for you guys. So we're going to first put down a sub n equals, that's always going to be the same, and then when we're writing our explicit rule. And then my first term, here it is 0, and then plus n minus 1 times, now what are we adding or subtracting? Well, we're going down, so we're subtracting. We're going down by 3, so that means we're going to have a negative 3 as our common difference. From there, we can simplify. We distribute that negative 3. So we should end up with negative 3n plus 3, because this is negative times a negative, turns into a positive. So you should get a sub n equals negative 3n plus 3. For b, we've got negative 2, 2, 6, and 10. Now, this one might be a little bit more difficult to figure out what the common difference is. So if you are having trouble, you'll take the second term minus the first term. So 2 minus a negative 2. This double negative turns into a positive, so it's actually 4. So our common difference is 4 for B. So if we're writing our equation, we would get negative 2, because that's our first term, plus n minus 1 times 4. From there, we distribute and simplify again. So we've got a sub n equals negative 2 plus 4n minus 4. We can combine like terms here, because negative 2, negative 4, that would simplify to a sub n equals negative 6 plus 4n. All right, 31, write a recursive rule or formula for each arithmetic sequence below. Here, again, we just still need to find a sub 1 and our common difference, but the formula is going to look a little bit different. So here our first term is 10. And then now for our recursive rule, all we're doing is substituting in for d. So what are we increasing or decreasing by each time? Here we're adding 11. So we've just got a sub n equals a sub n minus 1 plus 11. Okay, nothing too crazy there. Now for our other one, for part B, here we've got a sub 1 equals 0. And then for our common difference, we are subtracting 4. So this time we're going to want a minus 4, not a plus 4, a minus, because we're going down by 4 each time. Okay. Moving on. Oops, wrong thing. Given the recursive rule formula, write out the first 3 terms. Okay, so for the first one, we've got a sub 1 equals 5. So that just tells us our first term is going to be 5. Now, based on the formula, it's saying that we're adding 2 each time. So we're starting at 5, plus 2 is 7, plus 2, 9. For B, we start with a negative 3. A sub 1 equals negative 3. And then our common difference is negative 4. So we'd have negative 3 minus 4 should be negative 7. Negative 7 minus 4 is negative 11. All right. So that is number 32. Moving on. 33 through 38. We're dealing with some functions here. And we're going to evaluate and combine like terms for some of them. So 33. Here we're given f of -4. So this we have to remember is an x value. That's going to be our input. So here we've got f, so that means we're going to use the f of x function. So we've got f of -4 equals -2 times -4 plus 4. So if you wanted to, you could just type that into your calculator. You'd have -2 times -4 plus 4 equals 12. So when f of -4, when our x value is -4, the y value is 12. The other way that you might see it written is like this. Okay. 34. G of 0 equals, so G of 0 is our input, so we get 2 times 0 minus 3. This one you shouldn't need a calculator. 2 times 0 is 0, so we're left with -3. Now 35 says when when f of x equals 32. So we kind of give you a hint. We're solving for x. We don't know what x is. 32 is our y value. So we're going to take 32 equals -2x plus 4. We took 32 since that's what f of x was equal to, and set our equation equal to that. From there, you just solve for x, so -4 minus 4. 28 equals -2x. Divide by -2 to both sides. So you should get x equals -14 as your answer. 36. We've got 7 equals 2x minus 3. Solving for x, we want to get that by itself, so we'll add 3. 10 equals 2x. Divide by 2. So you should get x equals 5. And the coordinate would be 5, 7. Now 37 and 38, these are a little bit trickier, okay, but they're not too bad. So it tells you f of x plus 2 times g of x. Now what you're going to do is you're just going to take what f of x is equal to and substitute that in. Same thing for g of x. So I'll do f of x in blue still. So we've got -2x plus 4 plus 2, can't forget that, but then times, well, 2x minus 3, because that's what g of x equals. From there, we're just going to simplify. So here we can distribute -2x plus 4. 2 times 2x is 4x. 2 times -3, -6. Combine like terms, so we get 2x minus 2. That would be your solution. 38. Same dealio. F of x, g of x, but now we've got a subtraction sign. So it's going to throw a little curveball at us. F of x is still -2x plus 4, but now we've got negative or minus 2x minus 3. So what we've got to do now is we're going to have to distribute that negative inside our parentheses. So you should end up with -2x plus 4. That doesn't change, but we get -2x plus 3, because the negative times a positive is a negative. Negative times a negative. Oops. Should be a positive 3. Positive 3. But from there, we're still combining like terms. So -2x minus 2x, -4x. 4 plus 3 is 7. And that would be your answer. Okay, 39. State the domain and range for the relation. So here, domain, remember, are the x values. Domain are all of your x values. So in this case, we'll start with our smallest, so that'd be negative 7, 0, 6, 7. And the range, I'll do it, is the y values. So we've got, from our smallest, would be negative 2. Now there's two negative 2s, so we just need to include one of them. No sense in writing it multiple times. Oops, it should be negative 3. Negative 3 is the smallest. Negative 3, negative 2, and 4. Oops. It's not letting me scroll. There we go. Okay, 40. 40. F of negative 1 equals. So this is an x value. Okay, so you want to look at the x-axis. So here's where negative 1 is, and then we look for the y value. So it'd be 1, 2, 3. Negative 3. When x is negative 1, the y value is negative 3. Now when the x is positive 3, 1, 2, 3, we go all the way up. So 1, 2, 3, 4, 5. X, the y value is 5. Now we just flip it around. F of x equals negative 1. So what's our x value when the y value is negative 1? Well, when when y is negative 1, the x value is 0. When the y value is 3, 1, 2, 3, x value is 2. 41, write the function below that represents the sequence. Okay, so now we can remember we're going to use our explicit formula here. So we've got a sub n equals a sub 1 plus n minus 1 times d. So our first term is 8. It's an easy one. Plus here, so remember we're dealing with x's, so we'll have x minus 1. And then our common difference. Well, we look at our y values. Look at your range. What are you adding each time? You're adding 3. So our common difference here would be 3. And then from there we can simplify. So distribute that 3, so we get 8 plus 3x minus 3. Combine like terms, so your final answer would be 5 plus 3x. Couple more here, 3 more. So this one, it's not rocket science. All you're doing is now instead of f of 3, you've got f of x. So here your input is 3. See, the input's 3, input's 3. Now your input's x. So input is x, 2, x minus 4. Input's x, input's x. Okay. All right, so lovely word problem here. Luigi is training ponies to ride surfboards. He has 5 ponies that can ride a surfboard in month 1. Month 2, he trained 7 more. Month 3, he again trained 7 more. Write an explicit formula to represent any number of ponies. So this is similar to our, I can't remember who it was, but he was training squirrels to ride skateboards. I love that problem. So, but this one, so how many ponies could ride a skateboard or a surfboard at first? Well, it says 5 in month 1. What's our common difference? How many are trained after each month after that? Well, 7 each month. So from there, we've got a sub n equals 5 plus n minus 1 times d, which is 7. And so we'll simplify. And so your formula for ponies riding a surfboard would be 7n minus 2. Now we're going to use that explicit formula from, that should say from 43, the previous problem, sorry about that, to determine how many ponies were able to ride surfboards in the 15th month. Okay. So instead of a sub n, now we've got a sub 15. Okay, 15 is our input. So we've got 7 times 15 minus 2. Just like the problems that we were working with before, we could just type this into our calculator. So we get 7 times 15 minus 2 equals 103. So after 15 months, we've got a total of 103 ponies that can ride surfboards. All right, so I hope you enjoyed this video on Unit 3. You're going to do amazing on your midterm, and we can't wait to see you guys when you get back. All right, enjoy.